Welcome to clickmeproject.com. We discuss about joint physical layer and system level power management for delay sensitivity wireless communication. We consider the problem of energy efficient point-to-point transmission of delay sensitivity data over a fading. Existing research on this topic utilizes either physical layer center solutions, namely power control and adaptive modulation and codings, or system level solution based on dynamic power management. However, there is currently no rigorous and unified framework for simultaneously utilize both physical layer certain and system level technique to achieve the condition. In this paper, we propose such a framework. We formulate the stochastic optimization problems as a Markov decision process and solve it online using reinforcement learning. The advantage of the proposed online method is that it does not require prior knowledge of the traffic arrival and channel statics to determine the joint optimal power control AMC and DPM. It exploits the partial information about the system so that less information need to be learned than when using conventional reinforcement learning algorithm. It obviates the needs for action exploration, which severely limit the adaptation speed and runtime performance of conventional reinforcement learning algorithm. Our research shows that the proposed learning algorithm can converge towards order of magnitude faster than state-of-the-art learning algorithm for physical layer power control, up to 3 order of magnitude faster than conventional reinforcement learning algorithm. Now we discuss about the data flow diagram. It is consisted for transmitting data power control and stochastic optimization and power management. In this transmitting data, we have transferring the information of zeros and ones. It is transferring the information into power controller method. It is depends upon the adaptive modulation Q learning algorithm. We proposed a unified reinforcement learning algorithm solutions for finding the jointly optimization power control and AMC adaptive modulation coding, and the DPM dynamic power management policies whose the traffic arrival and channel statics and unknowns are known. We exploit a structure of the problem by introducing a post decision state estimating action exploration and enabling virtual experience to dramatically improve the performance compared to conventional oral algorithm. Our result demonstrate that the proposed solutions output performance exceeding the solutions even under the traffic and channel conditions. It also strongly support the use of system level power management solution in communication physical centric solutions to achieve the minimize the possible power consumption under the delay constraints in wireless communications. The output is given into receiver side. The receiver side is controller for stochastic optimization and power management. In this stochastic optimization, first in a traffic and change channel dynamics are only stationary over short time and interval consecutively for guests of cost that a policy will ensure fair in the futures are unreliable. They are based on part experience which does not have the so expected further cost should be discounted when making decision in each time slot. Second, we many indeed want to optimize the time average cost, but because the application lifetime is not known a prior, we assume that the applications will end with probability 1 in the any time slot appearance. The output is given into power management. The power management will be controlling all the process. The receiver primary concern has typically been the reliable delivery of the data to the receiver within the layerable delay. Increasingly, however, battery operated mobile devices are becoming the content We considered the case of the frequency non-selective channels where 2Hz denote the feeding of coefficients over the pointing point to link. In this time, the transmitter sent a data rate n of equal to t of s. The receiver where n equal to 1 is the number of bits per symbols deterministically by the modulation schemes. The AMC means adaptive modulations control components. All packages are assumed to have package length symbols period t find. The cumulative average cost will be representation of the 1, 2, 3 times 4. Each slot will be representation and the buffer company occupied levels will be displaying and the transmission action rate will be displaying. It is represented into the large multiplier. It is represented of the different time slots and the large update difference multiplier reference. The time slot output will be shown. It is represented into holding cost and time slot allocation level will be displaying. Thank you.